Okay, so hyperbolas are very similar to ellipses. The big difference is that first off, there's a minus in between the two fractions. That's how you know if it's a hyperbola or ellipse. And then one of the other really big differences is that the first fraction is always your a value. So for ellipses, a is the bigger value. For hyperbolas, a is always the first value. So in this case, a will equal 5, b will equal 7. So a comes from the first fraction, b comes from the second fraction. That does not determine horizontal or vertical. What determines horizontal or vertical for hyperbolas is which fraction comes first, the x or the y. So in this case, with ellipses, it doesn't matter. Addition is commutative. You could switch the order. For hyperbolas, subtraction is not commutative. So whichever fraction, either the x or the y comes first, that tells you horizontal or vertical. So in this case, since x is in our first fraction, that means it is a horizontal parabola. And our a value is going to go in the horizontal direction. So now from here, the center, same as always, the opposite of the x term, opposite of the y term, so we negative 3, 4. To find the c value, this time it's different because the foci are on the outside of the vertices, since the hyperbola opens towards those foci. So our formula now is just the Pythagorean theorem. So we have a squared plus b squared equals c squared. So in this case, 25 plus 49, which gives us 74. Whoops. So c is just the square root of 74, which for graphing purposes is approximately 8.6. And then something new we have with hyperbolas are the asymptotes, and that's going to help us with the shape. So the asymptotes from the center, we're just going to graph lines with slopes, both positive and negative, b over a. So in this case, it'll be 7 over 5. And I'll show you how that works now as we put it all together. So let's go ahead and start graphing this like we did in ellipse. We have our center at negative 3, 1, 2, 3, 4. So now this is a horizontal parabola, which means for our vertices, we're going to count left and right. Remember that a value that we're going to use is 5, so we count left 1, 2, 3, 4, 5, count right 5. The foci are going to go beyond that, so we'll count from the center though, so we already know that's 5, so now we have 6, 7, 8.6 for one focus, 6, 7, 8.6, kind of about space for the other focus. So now we don't actually have to make any points for B. B is just used in the asymptotes here. So from the center, so we're going to start with our center point. We're going to count slope of 7 over 5. So count up 7, 1, 2, 3, 4, 5, 6, 7 over 5. And then count down, continue that line the other way. I'm going to count down 7. Down here, that was 4, 5, 6, 7 over 5. So there's one asymptote. Try and make a dotted line. Our other asymptote is going to go the other way. It'll make a crisscross. So count up 7 again, left 5. Count down 7, right 5. There's your other asymptote. Essentially, as you make these, you should notice, let me get another color so you can see, your points for those lines are going to kind of create a little rectangle for yourself with the A's and the B values. So as you make those crisscrosses. Now we just have to graph the hyperbola. We have our vertex, it'll open out. Again, just use the asymptotes to help guide how wide or how narrow that hyperbola should be. And there it is. So again, things to keep in mind that kind of differ from the ellipse that we're used to. The A value is always the first value. Whether A is with X or A is with Y is what determines horizontal or vertical. So if A is with X like this one was, it's horizontal. If it was a Y in that first parenthesis, it's vertical. From there, find the center like normal. Find your C value by using the Pythagorean theorem. And then to get the shape of your parabola, you graph your asymptotes. And you just use B over A to get the slope, count that slope out from the center of the graph. Okay, so now we're going to do one where it's not in that easy form to deal with first. So just like before, in order to get it into that form, we're going to have to complete the square. So we'll group our x's, group our y's together. Now the one difference we notice here, the x squared is our negative term, so that means it's going to be the second fraction. So it's not always going to go x's and then y's this time. You're going to do your positive fraction first, your negative fraction second. So as we're writing this out, we have y squared. That one's already done. So now minus, just like with ellipses, if there's a coefficient to the square, you need to factor it out. So we take that 5 out, and now here's the big key with hyperbolas. That's a really easy mistake. Technically, we're taking out a negative 5 there. So what's left in the parentheses is the x squared, but then a minus 4x, because we have to do 20 divided by negative 5. And then here's where we're going to need to complete the square. So I'm going to add the plus blank, and equals 50. And then again, technically it's plus blank, but we took out a negative 5, so it's negative 5 times whatever we have. So now we complete the square. Negative 4 divided by 2 is negative 2. Squared is 4. And fill that into both sides. So now we have y squared minus 5 times x minus 2 squared equals, and over this side turned into 50 minus 20. So that equals 30. And now just like ellipses, needs to equal 1. So divide it out. And we have for our final equation, y squared over 30 minus, I'll fix that 5 in just a second, over 30 equals 1. Again, just like ellipses, bring that 5 down. And 30 divided by 5 is 6. So now we can figure out all of our pieces. First off, like we said before, the a value just goes with the first fraction, the positive fraction. So in this case, since y is first, that means this is a vertical hyperbola. Then that a value is the one that goes with y. So a is going to be the square root of 30, which is approximately 5.5. B is going to be the square root of 6, which is approximately 2.4. And then our c value, we do a squared plus b squared to get c squared. So we have a squared 30 plus 6 is c squared. C squared is 36, so therefore c is going to be 6. So there's all of those pieces that we need to graph. And then our center, just take from, just like we've done for all of them so far. Now here's where you have to be really careful. It looks like you want to say 0, negative 2. But keep in mind, we have to look at what is with x first. It could be the h, so this is a negative 2, 0 center. So be really careful with vertical parabolas that your center is the number with x and then the number with y. It's backwards from what you're used to looking at. So now we are ready to graph this. Center at negative 2, 0. This one is a vertical hyperbola, so we're going to count up and down a. Down, 5, 6, over. And then our foci was C is 6, so it's going right next to it for our two foci. Now we just need the asymptotes so we can kind of see the shape that this is going to make. And for the asymptotes, count is plus or minus b over a for their slope. So in this case, is going to be, we'll go 2.4 over 5.5. So I count up 5.5 over 2. That's my 1.4, about there. Should be in line with the top one. Down 5.5 over 1, 2.5. There, and then there's one asymptote. The other asymptote up 5.5 over 2.4. down 5.5 over 2.4. And here's my other asymptote. So again, notice they kind of make a little box here. You can see a bit of a rectangle with how those play out. So now last step, just actually graph the hyperbola. It goes through its vertices and then hugs the asymptotes. And that's it. So try those next two problems in your notes. I will check them tomorrow and we will go through them, address any questions. Just use that chart, use these videos to kind of help yourself through to try and get those graphs done.